Okay, here's our Algebra 1 Regents video. This is the first video in the course. We had two others, 1A and 1B, and they were prerequisites. So we're going to start with 2A, equations with variables on both sides. Okay, let's go right away. Here's the first question. So see if you can answer it first if you want to pause the tape. If not, let's go right away. Let's use green. Why not? So right here, you see we have to distribute right away. This will be 3x. Remember, we're distributing the 3 in the parentheses. 3 times x is 3x, and 3 times negative 3 is negative 9. And we'll bring that minus 3 over. And do it slowly and make sure you have everything intact so you can see if you made a slight mistake. And it's very easy to make mistakes when you're doing these. So now let's clear this up. A minus 9 minus 3, let's clear it up. Let's combine. Remember, you can combine like terms, and these are like terms. These are constants. And this will be a negative 12 or just minus 12. You don't care about the semantics, right? And you should know why it's negative 12. Remember, keep, change, change. Negative 9 plus negative 3. Remember, just in case, negative 9 minus 3 is negative 9 plus negative 3. Keep, change, change. So that's why it's negative 12. So now we can do the constants first or the variables first. So it doesn't matter, but let's just use another color, use red, why not? I'm going to minus 3x on both sides because we want to do the opposite operation, and since there's nothing here, we call it a positive, so we want to do a negative. So that'll cancel. Remember, whatever you do to one side, you have to do to the other in algebra. Remember, the equation divides both sides. So we have a minus 12 or a negative 12 equals 5x plus 3. 8 minus 3 is 5, right? So that's pretty simple. And now we want the x alone, so let's get rid of this 3, do the opposite operation. We have a plus 3, so we do a minus. That'll cancel. And whatever you do to one side, guess what? That's right, you do to the other. So this would be a minus 15 equals 5x. We want to do the opposite operation. We want the x by itself. So we're going to divide the 5 on both sides. And guess what? X equals negative 3. All right. And now if we wanted to check this, we know that x is negative 3, so let's just double check. I'll clear that out. You can always rewind the tape. So when we know x is negative 3, put that negative back in there. So let's plug in negative 3 for x, and we'll see if we get the right answer. If we didn't, we did something wrong. All right, so on this side, we have negative 24, because 8 times negative 3 is negative 24 plus 3. So we know on this side, we already have negative 21. We have to get negative 21 on the other side, or else we did something wrong. So in the parentheses here, we have 3, and negative 3 minus 3 is negative 6. And don't forget PEMDAS or GEMDAS. So this will be negative 18 minus 3, which is negative 21. So yes, it checks out. All right, let's move on. Do another. See if you can do this one. Now you notice here it has an m. You don't care if it's an m. You don't care what the variable is. Just solve it, right? So in this case, we're solving for m. Solve for m. And you'll get many of those on the Regents. Maybe they'll say solve for q. Maybe you solve for r. You don't care. If it's an x or r or y, it's the same thing. So again, we're distributing here. So we're going to have a 2m minus 6 minus 3 equals 8m plus 3. Let's clear this out again. So we're going to have a 2m minus 9. Minus 6 minus 3 is minus 9. And you have 8m plus 3. There we go. Now, you could minus the 8m if you wanted. You can minus the 2m. You can minus 3 or add the 9. Whatever you want to do, do. Now, I usually always subtract the variable and coefficient first, and usually I take the lowest one, but it doesn't matter. You're still going to get the same answer. So I'm going to minus the 2m on both sides. So we have a minus 9 here. This is going to equal 6m plus 3. We want to minus the 3 on both sides, because remember we're doing the opposite operation here. And we're going to have a negative 12 equals 6m, and let's use another color. We'll use purple. There we go. Divide out the 6 on both sides, and m equals -2. All right, let's keep going. Clear that out. Again, you can rewind the tape, and let's see what if we can do this answer now. What do you think about this one? So we'll change the pen. Let's go to blue. Why not? So this one's a little easier, right? You can minus the 3. So let's just write it again. Here we're solving for x. Again, you don't care what the variable is. Minus the 3x on both sides. And now we're going to have 8 equals 2x. Divide out the 2. And x equals 4. Right? Double check, right? So 4 times 3 is 12. 12 plus 8 should equal 5 times 4. And it does. 5 times 4 is 20, and 12 plus 8 is 20. Moving on, clear that out. Let's go to the next question. This is solving for g. See if you can solve for g. Pause the tape if you have to, if you want to. Otherwise, let's keep going. So we have solving for g, and we'll go back to green, right? So in this case, maybe let's minus the constants first. Doesn't matter. I'll minus the constants first. And I'll have 3g equals 5g. And we have a -9 minus 3, which gives us -12. Now, I don't want to minus the 3g because that'll give us a 0, right? We don't want that to happen. So I'm going to minus the 5g on both sides. That will cancel out. And here we're going to have a -2g equals -12. And if we minus the 2 on both sides, now we have two negatives. So g is going to be 6. It's going to be +6. Let's do it again, but let's just do it a different way instead of to show you that it doesn't matter which way you do it. So write this up here again. 3 plus 3g equals 5g minus 9. What if I just minus the 3 right away? Right? Now that will cancel out. And so I have 3g here equals 5g minus 12. We're going to get the same thing. It didn't matter what I did. The same thing. Right? Well, let's do another one. What if, let's use this color. We'll put it up again. What if I did something different? Like, what if I got rid of the 9 right away? I just wanted to get rid of the 9. Why not? Right? So I'll just add the 9 on both sides. Do that. Right? Now I have 12 plus 3g equals 5g. So I want to minus the 3g on both sides because I don't want to minus the 5g. Then we'll just get 0. We don't want 0. Right, that'll cancel out. And we have 12 equals 2g, and we get the same answer. G equals 6. So see, it doesn't matter which way you do it. You'll get the same answer. All right. Okay, so sometimes you'll see it says, what is the value of Q? Or whatever. It doesn't really matter. Same way. Right? So doing these over and over again, just so you get it. So over here, I see a -1, so I'll add a 1 on both sides. Just add a 1 on both sides. Now I have 5q equals 2q plus 21. And now I can get rid of the 2q on both sides. And I'll have 3q equals 21. Divide out the 3 on both sides. And q equals 7. Okay, moving on. Again, rewind the tape if you did not understand that. And let's get the next question. Here we go. Here you see 2 parentheses on both sides. You have to distribute. Be careful how you distribute, too. Use purple. Why not? Let me distribute over here. I have a 3x plus 3 minus 5x. Now we have 2 variables that we have to combine. And we have a 12. And here I'm distributing the negative. Be careful there. So it's -6x and it's going to be plus 7. Negative times a negative is a positive, remember. So be careful right away. That's what you should have had. So let's clear up both equations here. We can combine like terms. We can combine these terms over here, and I'll have negative 2x. So we're going to have, it's a positive 3, so it's a negative 2x plus 3 equals, and here we can combine the 12 and the 7. So that'll be 19 minus 6x. So if you didn't understand that, you should rewind the tape. All right, and let's just change the color for a minute. So, by the way, I could have did this little thing over here. Instead of negative 2x plus 3, you could also have done 3 minus 2x. Same thing, by the way, over there. Doesn't matter. And like this one here, you could have did negative 6x plus 19. Could have did that also. Remember, there's nothing there, no sign, so we make it a plus, positive. So let's minus the 3 on both sides. That'll cancel. We have a negative 2x down there. Remember, whatever you do to one side, you do to the other. So we have a 16 minus 6x. All right, and now we can't minus this. We can't get rid of this negative 2x because that'll give us 0, so we have to actually do the opposite operation here. That'll cancel. Whatever you do to one side, you do to the other. So now we're going to have a positive 4x equals 16. And if we divide 4 on both sides, x equals 4. So we solved for x. Always double check your work. All right, so let's move on. We'll try this last problem for this video. And then in the next video, we'll show how to use the calculator to solve some of these questions. All right, so again, distribute. So we're going to have and let's get the pen back. Let's get the green today. Negative 4y and plus 12. Remember your signs. Be careful about that. And this will be 10y minus 30. Very easy to make mistakes, so you want to take your time. And so if I want to get rid of the y, I'm going to have to add the 4y. That'll cancel. Whatever you do to one side, do to the other. And 12 is going to equal 14y minus 30. So what do you think I have to do next? Why do you think I shouldn't minus the 12? Why? Because if I minus the 12, then I'll get a 0. No, we don't want to do that. So I'm going to add the 30, doing the opposite operation. Whatever you do to one side, you do to the other side. So let's change the color here. So what do you think this will be? Okay, so we have here 42 equals 14y. Again, the opposite operation of multiplication is division, so we'll divide the 14 on both sides. And 42 divided by 14 is 3, right? So y equals 3. Okay, so that was equations with variables on both sides. In the next video, we'll talk about how to use the calculator for that, and then we'll get into more topics. So great job. And let's put an emoji. Why not? Let's put a little sticker that we did a great job. You did a great job. Boom. Good. All right.